Today we're going to use the information we talked about yesterday on slope-intercept form to take an equation in slope-intercept form and graph it on a coordinate plane. Yesterday we talked about the different parts of the slope-intercept form equation. We talked about how m stood for slope, which was right here in the equation of the line. The slope of the line is your rise over run on the graph. We also talked about the y-intercept of the line, which is the b value. The y-intercept of the line is the point where the line crosses the y-axis. So you can see on this line on the coordinate plane, the y-intercept would be right here. It is crossing the y-axis at a positive 3. So the b value is a positive 3. So this is where we're coming up with the equation of the line of y equals 2x plus 3. Now the slope of the line is a positive 2, meaning that 2 is our slope. I can write 2 as a fraction as 2 over 1. So this is my rise over run on that line. So starting from this y-intercept point, I can go up 2 and over 1, and then I will be at another point on that line. I could also change this fraction to be written as negative 2 over negative 1. Because if I have a negative in the numerator and the denominator, it will turn that back positive. So I could also start at my y-intercept and go down 2 and 1 to the left. Because these are both negative, so a negative rise means I'm going down, and a negative run means I'm going to the left. And I would also be back on the purple line. Today we're going to talk about using that equation and drawing the line. So for our first example, we start with steps to graph a linear function. The first thing we're going to do is graph the y-intercept. And remember, the y-intercept is the point where the line crosses the y-axis. The y-intercept is also our b value in that y equals mx plus b equation. Then we're going to use the slope of the equation to rise and run to another point on the line. And our last step is going to be to connect the points with a line. So for our first example, graphing the function y equals 2/3 x plus 3. You can see in this equation that the 2/3 is the m value. That is our slope, which is also the rise over run. The plus 3 in green is the y-intercept. That is the b value. Because remember, we're following this form of y equals mx plus b, where the number that's attached to the x is the slope, and the number that's added on at the end is the y-intercept. So I have a y-intercept of positive 3. Remember, y-intercepts are in the form 0, b from our flip chart. So that means I'm going to have the point 0, 3 on my line. So I go 0 on my x's and up 3, so you can see the green dot on the graph. That's my y-intercept of positive 3. Then my slope is 2 over 3. It's both positive, so I'm going to go up 2 on my graph, and then I'm going to go to the right 3, which notice puts me at another point on my line. I have 2 points, so I could connect them with a line. But you will notice that if we continue with that slope, we're going to continue lying directly on that line. So if I continue to go a rise of 2, a run of 3, then I will still be on that line. If I rise 2 and I run 3, I'm still going to be on that line. Same thing here. If we want to go in the other direction, I can rewrite 2/3 as negative 2 over negative 3. Those are the same fractions because a negative divided by a negative would cancel each other out and turn back positive. So I can also start at my y-intercept line and go down 2 and then 3 to the left. And notice I will still be on that line. Down 2 and 3 to the left, I'm still at that line. This is our first example on how to graph a function. Now let's try another one. Y equals negative 3/4 x. Remember, with fractions, our negative sign, if we have a negative fraction, the negative can go in the numerator or the denominator, but it cannot go in both. So when I talk about a negative 3/4, negative 3/4 can either be written as negative 3 over positive 4, or it can be written as positive 3 over negative 4. So I'm going to use either of these as my rise over run, because remember, this is still my slope. I'm also going to use my b value in this equation to start out. So my first step is graph the y-intercept. My y-intercept is a -5. That's my b value. So I'm crossing the y-axis at a -5, which is down here. Then I'm going to use my slope of -3/4 to find another point on the line and connect them together. So I can choose this first example, which tells me that I have a -3 in my rise. So I'm going to go down 3. And then it tells me that I have a +4 in my run. So I'm going to go to the right 4 after I go down 3, which would put me right here. Notice I would go down 3 and to the right 4. If I choose to use the other example of this fraction, that fraction is telling me to rise up 3 and then tell me to go a run of -4. So I'm going to go to the left, -4, which would put me right there. So then I could graph another point on that line right here. Now I can connect those points together best I can and create a line for that function. So this would be the function of y equals -3/4 x minus 5. In this function, y equals -x plus 9. Here we have a y-intercept of +9. So that means I'm crossing the y-axis at a +9, which would be right up here. Then I look for my slope. My slope in this equation of the line is the number that's attached to the x. Remember, when there's just a negative sign in front of the x, this is really like -1x. So my slope of this line is a -1. Now that doesn't look like a fraction to me, but remember, any whole number can be written as a fraction by putting it over 1. So this is my rise over run. So it's telling me I need to rise -1 and run a +1, so to the right 1, and then I have another point on my line. I can continue to do this throughout the entire graph and graph multiple points to connect together on my line, which would look like this throughout the entire graph, and then connect them together with a line.